This is Nathan, 7A math teacher, and for this video, we're going over 4.1 factors and prime factorization. Let's start. So what are factors? Well, factor is a number that divides another number exactly and without zero, and without remainder. So an example of that is 2 and 10. 2 and 10 are factors of 20. You know why? Well, if you divide 20 with 2, you'll get 10. That has no remainder, so that's why 2 is your factor. And 10, if you divide 20 with that, you'll get 2. That means that means 20. 10 is a factor of 20. Anyway, let's start. Let's have more example. 36. We want to list all the factors of the given number. 36. First of all, we're gonna let's have the easiest two whole numbers that multiply. If you multiply them, you get 36. You'll get 1 times 36. Then the next number is 2 times 13. And the third possible way is 3. Oh no, not 2 times 13. My bad on that. 2 times 18. And the third possible way is 3 times 12. And then you think, is there any more? But what if you don't know, right? You don't know the product. So what you do is you think of a number between 3 and 12 and you divide 36 with that. For this one, let's go with the next number, 4. 4 divided by 36 is 9. So that means 4 times 9 is 4 times 9 is equals to 36. Now, is there any more? Go check. Think of a number between 4 and 9 that divides 36. 5, you cannot. 6, what is 36 divided by 6? 6. So that means we have 6 times 6. Is there any more? No. Why is that? Is there any number between 6 and 6? No. So that was all the factors of 36. Now let's list all of them. 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are all the factors of 36. Let's have another one. 44. Again, first thing first, you want to list the product of two whole numbers in all possible ways. So first product is the easiest one. 1 times 44. The next one is 2 times 22. And then the next one, we cannot divide 44 with 3, so we go 4. And you'll get 4 times 11. 4 times 11. Is there any more? Well, let's go think of the numbers between 4 and 11 and divide 44 with that. 44 divided by 5, you'll get some decimal, or you get a remainder. 44 divided by 6, you'll get decimal or remainder. 44 divided by 7, you get decimal again. 44 divided by 8, you'll get decimal. 44 divided by 9, you'll get decimal. 44 divided by 10, you'll get decimal. And that's all the numbers between 4 and 11. That's why those are that's all the possible ways. Now let's list all the factors. We have 1, 2, 4, 11, 22, and 44. So what we're basically doing is we're getting all the numbers that we just written and we are rearranging them from least to greatest. So first of all, write all the factors of a number. How about you guys try? You can pause the video here and try on your own. Welcome back. Hopefully you guys did practice, did factoring by yourself, or you paused the video. So let's list all the factors of 31. Well, we have the easiest one, 1 times 31. Is there any more numbers between them? Nope. We cannot we cannot divide 31 with any more any numbers with anything else actually. So the factors of 31 is simply 1 and 31. How about 87? Did you guys try 87? So first is 1 times 87. The next is 3 times 29. Is there any more? Not really. So the factors of 87 is simply 1, 3, 29, and 87. That's it. So to do factors, you simply have to know your multiplication table. Okay? Multiplication table is your friends when is your friend when you're doing your prime factorization. I mean when you're finding factors. Even calculators cannot help you with this. The multiplication table is your best friend. Or if you memorize multiplication table, then you're pretty good at this already. So now that we know factors, let's talk about prime numbers. A prime number is a whole number that is larger than 1 and it has exactly 2 factors, 1 and itself. So let's think of a number 6. Is 6 a prime number? Well, it has 1 times 6 as a factor, right? However, 6 also has 2 times 3 as a factor. Hence, 6 is not a prime factorization. So example of prime factors, our prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so forth and so forth. Again, you guys don't need to memorize all the prime factorization, but I do want you to know to at least know at least 5 prime factor. At least know at least 5 prime numbers. Okay, prime numbers up to 11. Okay, that's it. Or 13 if you want. If you're feeling daring, then go up to 23. So notice two things. 2 is the only prime number that is even, and 1 cannot be prime number. Okay, 1 is not prime number, and 2 is the only even prime number. The opposite of a prime number is a composite number, which is a whole number larger than 1 and has more than 2 whole number factors. So an example in this is 31 is a prime number, and 87 is a composite number. 44 is also a composite number. 36 is also a composite number. Now we're going to combine what we learned, prime numbers and factors, in prime factorization. Prime factorization is simply the method of rewriting a number as the product of prime numbers. And to do that, we can use a factor tree. Okay, this is like a tool to find a prime factorization of a number. So how do we do prime factorization? Well, first of all, we're going to start by dividing the number by the smallest prime number we can. And then we continue until only the numbers left are prime numbers. In other words, we only stop when the ends of our factor tree are all prime numbers. Then write the number as a product of prime numbers. So first example is 228. So first of all, we're going to write it to, oh shoot, it's all the way right here, 228, and we're going to factor tree that. So what are so the smallest prime number that we can divide 228 is 2. 228 divided by 2 is 114. And then this is a prime number, so we cannot do any more. 114 on the other hand is a composite number, so we wanna divide that even more. Again, we'll use 2. What are 2 times 4? 114 divided by 2 is 57. And then 57, is it a prime factor or a prime number or a composite number? It's a composite number. So 57 divided by 2, well, we'll get a decimal, so we cannot use 2. Let's move on a bit higher. 57 divided by 3. 57 divided by 3 is 19. So we get 3 and 19. Is that all? Is 19 a prime number? Let's go check. Yes, it's a prime number. That's why that's why we stop. So we're going to rewrite this, and then we're just going to rewrite 228 is equal to 2 times 2 times 3 times 19. And that's all. That's how you do prime factorization. You're going to rewrite 228 with all the endings. Okay? Let's draw a blue line. This is factors of 28. This is factors of 18, of 114. And boom, 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 boom. This is factors of 57. Notice that, again, we're not factoring to 2, and we're not factoring the prime numbers. We're only factoring the composite numbers. Let's have another example. Two examples. 189. So again, first of all, we start with 189 at the very top, and we find two numbers that divides 189. 189 divided by 2 is not possible, so let's try 3, and you'll get 63. So we can put 63 right. We can split 189 to 3 times 63. Next is 63 divided by, again, we cannot do 2, so we just go 21. We go 3 again. 63 divided by 3 is 21. So 3 and 21 are factors of 63. So we get 3 and 21. Again, we'll just use 21. Any factors of 21? Yes, it's 3 and 7. Is that all? Is 7 a prime number? Yes. So 189 can be written as 3 times 3 times 3 times 7. How about 300? Again, we want to factor 300, so first of all, we write 300 at the very top. And let's start with the smallest prime factor, our prime number that divides 300, 2, and you'll get 2 and 150. Next is 150 again. Now we'll focus on 150. Again, we're using the smallest prime number first, which is 2. 150 divided by 2 is 75. 75, can we divide 2 with that? No. Can we factor 3 with that? No. How about 4? No. So how about 5? 75 divided by 5 is 15. Or 75 divided by 3? Oh, my bad. We can use 3. So we'll use 3, and you'll get 25. And then this one is 25, can be split up into 5 times 5. So 300 can be written as a factor of 2 times 2 times 3 times 5 times 5. And that's basically it. How about you guys try 56 and 420? Find the prime factorization of each number. Pause the video here. Okay, let's hopefully you guys tried it. 56. So first of all, start with 56, the very top. Two numbers that divide 56. Start with the smallest prime number, 2. And 56 divided by 2 should give you guys 28. Again, start with 2 again. You'll get 14. 28 is 2 and 14 is 28. Now focus on 14. This is simply 2 times 7. So 56 is basically can be written as 2 times 2 times 2 times 7. How about 420? Did you guys get it already? Okay, let's try it. 2 times 210. 210 divided by, again, we'll start with the smallest number, 2. And you get 105. Now let's do 3. 3, you'll get 3 and 35. And this is simply 5 times 7. Is that all prime numbers at the very end? Yes, so that means we stop. 420 can be written as 2 times 2 times 3 times 5 times 7. Again, we're just simply using at the very end of our factor tree. Nothing fancy, we're just using all the numbers and we're rewriting it as a product. And then that's it. Don't worry about factor monomials. Just focus on our just focus on prime factorization. Okay? That's the end of the video. Have a great day, and I'll see you in the next video. Goodbye.